Okay, welcome to Nested Loops. We're going to continue with the bridge pattern. I'm suggesting we back up. It's been 2 weeks, and this is the hardest pattern in my mind to understand in general. So I figure we'd back up a few pages, maybe back to 115 or so, and re-review how we derive or come up with this pattern and how it's different, because really it's like one level of indirection I think makes the big difference, and it's not intuitive. So I'll leave it up to Diego, but I think that would be useful. And at the end we can quiz Andrew and see how well the review worked, because this really is in my mind the hardest pattern to understand in the book. So with that, I'll turn it over to Diego.
All right, you guys can see my screen. All right, so pretty much going back to the derivation. And now I wonder if I should go back far. Like before we had, I'm just gonna remind what we had. We had a client using perhaps like a shape. Can you guys hear me?
Yeah, I hear you fine.
Okay. A client using a shape class that calls draw, and that shape is just like an abstract class, and every actual concrete class has all the information to draw. It knows whether it's what kind of shape it is, rectangle versus circle, and it also knows that is what program is going to do the drawing portion of it. And so in reality, what the client uses directly, like a V1 rectangle, V1 circle, V2 rectangle, V2 circle. So the client actually knows which shape it is and whether it's the version 1 or version 2 type of drawing at the very end, what actually does the drawing. And potentially, like, it knows something about the implementation, how this is going to be implemented, and what kind of object I'm going to use. So over here, and this again is the sequence flow. The client has an instance of V1 rectangle called my rectangle V1 rectangle, and pretty much the cause itself does the translation to this kind of like a domain adapter pattern to like whatever the drawing program is, and keep going until it draws the whole thing. So going back to the deriving it, we talked last time that so like the normal way with object-oriented programming is like we try to identify all the nouns that are present. We get shape, we get drawings, and then you try to attach actions which make up the methods. And the author here wants us to like look at different way of looking by using commonalities and variability. So there's a commonality analysis and a variability analysis, which everything that is in common will give you what the abstract classes on the high level, what the concepts are, and the variability will give you each implementation. And also, so like Francis said, and the two of the kind of rules from the Gang of Fours is like find what varies encapsulated, favor aggregation over inheritance, are kind of like two of the guidelines that we should look for and should use. Actually, I say consider, like it makes a point later on talking consider versus using. He also talks about what encapsulation also means. It's not just the encapsulation of data, but also encapsulation of implementations. And again, you know, what varies and what encapsulated. Like if you look at even at this diagram, we know what varies are the shape, the type of shapes, right? And the type of programs. So we know we need to encapsulate somehow the shapes and the programming and drawing programs in some way. All right, going back here. I need a second to reacquaint myself with this. Oh, actually, like that's actually what it did. Like by looking back there, we saw that we have a shape and drawings, and drawings has like a V1 drawing, a V2 drawing, shapes as a rectangle and circles, and then it eventually is trying to say, okay, how do we tie these two things together? And we said, well, if we use aggregation this way, we're gonna know the shape has a drawing, right? So it actually uses a drawing. So shape uses drawing, and by doing that, we let me think about this. So if it's over here. If shapes uses drawing, shapes will need to know what type of drawing object they use, and the client would not even know what kind of implementation it has. It just knows it has a rectangle or a circle. But in let's see. At some places it does also the oh, okay, it's right here. It considered the opposite. What if it was the opposite, that the drawing uses a shape? And it does like this analysis or consideration, I should say, mainly as a mental exercise, just to see all the possibilities of how you could pretty much skin this cat. It's like, which one would make more sense? If a drawing were to use a shape, it would pretty much like, it talks here about like via encapsulation, because the drawing will have to know specific information about the shape, meaning what kind of shape it has to draw. So, and it evaluates, consider the solution first. So moving on. So now that we know we have a shape that uses a drawing, and the drawing has a V1 drawing, a V2 drawing, which have like a similar API or interface. Now we can actually implement in this section like an adapter pattern. This is what this is. That interfaces the actual implementation to what the concrete final calls are going to be. And so we have a shape abstraction completely separate from a drawing implementation. So again, one of the points of the bridge pattern is the separation between the domain model, between the domain model problem and the implementation of the specifics. As a side consequence, we have a bunch of different things that are good, which are One is this like one rule, one place. Again, before, and I'll go back in the previous, see, like in the previous implementation, each shape, like this draw, knew it would draw like a rectangle, so it go like from point to point to point to point. But to do that, we do call draw line, and its parent class would know actually how to implement it with the V1 shape. Now, the V2 rectangle was doing the same exact thing, but had another way to call draw a line. And so like you have like a redundancy of how to draw a rectangle. Like you go from point to point to point to point. You have like a specification inside of this draw method and inside this other draw method. Circle, same thing. You draw a circle. You're gonna call this method aside, but you're gonna do again over here in the new one. There's no duplicate of how you draw a rectangle. There's no even a duplicate how you draw a line for DP1 or draw a line for DP2. So this helps with testability, because in the previous example, if you had to implement, so like right now we have to, like, for example, test only like, one method here, one method there, method here, method there. So like how many shapes I have, plus how many drawing system I have or drawing methods I have. That's all you have to test. In the previous implementation, it was like a multiplication of the two, because you will have rectangle 1 V1, rectangle 2 V, rectangle 1 that draw, rectangle 2 that draw, circle 1 that draw, circle 2 that draw, and so on. And if you add like a third drawing system or a third shape, you will have like 9 different things. Like it will grow exponentially, pretty much. Like it will, 3 by 3, 4 by 4, and so on. But right now it's kind of linear, because if I add another shape, let's say a pentagon shape, I only have to test the draw method. I don't have to add any test for V1 drawing or V2 drawing based on the new shape. And if I were to add a V3 drawing, I will only have to test draw line and draw circles. So 2 more tests. And again, it's because now you have the rules to how to draw a rectangle in one place, the rules how to draw a circle in one place, and so on.
Yeah, and I think that example really sums up right above the one rule, one place class diagram, illustrating separation of abstraction and implementation, which as a sentence I think is very confusing, and even right now might still be confusing for some of you. But you can see the abstractions are the shapes on the left, shape abstraction, and the implementation is the different drawing things. And part of that key is that adapter level where he extracts the common interface. You have different lines, you need adapters, but you draw shape with lines and circles and possibly ovals and whatever those rules are. So the shapes can change, you can add new shapes, and the drawings can change. So abstraction, separation of abstraction, implementation, it's like, that's kind of how they define what this is for. And that's the part that's confusing, because this is not really, this way of organizing is not intuitive. You never would have come up with it with the noun verb thing. I think unlikely to come up with it. So I'm emphasizing this. And I think if you think about some stuff where you had to cut and paste, say, domain knowledge, basically how to draw like in different places. I'm hard to figure out a real world example off the top of my head, but I think all of us are thinking, oh, I have to cut and paste this, and can't figure out where to go, and literally, it's almost like, here, this is a smell for the bridge pattern if you're pasting this domain thing, or you have here, and you have the same code that you couldn't figure out how to get out. It's because instead of putting it here above and inheriting, it's actually below, in this case, in the drawing implementation. So anyways, and I'll turn to Andrew, because I think he's being the most junior part of the team is probably the most confusing for him.
Yeah, and in the previous implementation, it was like a monolithic hierarchy, right? You had like one shape that also knew how to draw, and now you separated the two things.
Yeah, and that makes sense. The object knows how to draw itself. It makes sense from the intuitive thing, but it's bad but it doesn't make sense in the bridge.
Right. So, and here he talks about like the bridge pattern. Let me see the viewing the implementation as something outside of the object that is being used by the objects.
Yes, and I think that's the key. That's the weird part. Usually you figure, oh, object knows how to draw itself. So the implementation and the data and the responsibility all kind of the same. But here we're literally saying, oh, the implementation, we're going to abstract that again. So I know in general how to do this, but the specifics I don't, which I don't get to another object. And that I think is really key. And so now,
the other thing that about is like when the client gets an instantiation of the object, he knows that it has a rectangle or a circle, but he doesn't know anything beyond that. Before he knows what was a V1 or V2 or one of those shapes. So like, so once he gets an object, he said, so the client can tell because they look the same. They both have a draw object. Now the shape cannot, again, knows that it has a drawing, but it still doesn't know necessarily whether it's a V1 or V2. Now the drawing is the only thing that knows what the interface is with. It knows that it uses like the 1 or 2 diagram program. So then it goes through actual Java code, which this will be like the client uses factory to get all the shapes, so it has no idea what shape it actually has, because it draws on all of them. This is the abstract class that has just like a draw line, draw circle for the shape, and it knows it takes a drawing as part of it. So the rectangle inherits, has the logic, how to draw itself, and it calls draw line on the drawing that is being instantiated with. Again, he doesn't know whether this is like a 1 or 2. You just know that it's a drawing in response to draw line, nothing more. Circle, kind of the same thing. We call circles on it. And now the drawing, again, it's another abstract class that has either draw line or draw circle methods with a common, again, what this does just provide a common interface. And then V1 and V2 drawing actually call directly the DP1. This is like the only thing that's sort of knows of what actually interacts with. Like over here, the abstract class, of course, doesn't know. Yeah. So for that.
All right. So if we pause here, if you get the stuff we were talking before, the code pretty much represents, especially that last picture, 3 objects.
Yeah.
And if you don't get it, you're going, oh, I kind of get it. So this is the chance to pause and ask questions. Andrew, Brett, Don. I know Don has to catch up on the whole chapter. Scott.
I probably missed it from the beginning, but what's starting the whole chain? Like that top part, the client is.
So again, the question.
Is there any description on like what it's trying to do, or like maybe I missed it, or maybe it's not there? Like we're just calling main on client and that's it.
Yes. So pretty much, there's a factory, and yeah, like the software pretty much in this case calls main. Like in Java, that's how it works. You instantiate, like you call main on the master class, and in terms of main, instantiate the factory, gets all the shapes that it needs to, that they being defined.
Yeah, where do those shapes come
somehow.
from? Yeah. Okay. Yeah.
Right. So,
cool.
this factory might get called get shapes, and the get shape might be from a file. Like it could be like some kind of definition of objects, in a YAML file, let's say. And in the YAML file, it will have, if it's a YAML file, but could be like a database or whatever it is. Could be memory. It gets the actual shape that been instantiated, or representation of those objects. They've been instantiated with the correct drawing, right?
Cool.
So
and is there any pattern that's very similar to this? It doesn't seem that complex.
All right, so let me go back to this. That factory is another example of encapsulating what varies. So he didn't actually name it a good thing. My factory indicates the factory, but you don't know why. But the idea is V1 and V2, even getting the shape is different. One might be like said YAML, one might be in memory. But the idea is you have something that gets you the shape. And once you have the shapes, which is abstract, all you do is you loop and you go over and draw. So
right.
The beauty of the client here is, and it's not the bridge pattern. The factory is not a bridge pattern, but it's how he feeds into it. Let's say we have a V3 program, and I have a V3 factory, which again, factory is not what you're going. It's really kind of a shape getter. Use a factory, but factory is a generic sense of I don't need to know what it is. I just know I get it from it. So I can have a V3 factory shape getter that gets me all the shapes, however, and that might be through telepathy or whatever. But all I need, the client knows, is I got a factory to get the shapes, and then once I have the shape, I tell them to draw. So the beauty is client never changes. I just make a new factory class, and I pass it to this. And of course, I have to make the other classes a draw. So that's the question with the client. That's why the client set it. That's the beauty of the pattern, is the client just has the shape getter and it draws shapes, which is just draw. And then your other question, is there a pattern similar to this? The bridge, I don't think there is. That's kind of why I'm spending the time here. It's like coming up with a solution, I think, is hard if you're not used to it.
This seems common. Like something I would do often. But
like using the bridge pattern?
Yeah. So that's why I'm like, am I missing something? Yeah. It seems common that you'd have this abstract thing that you call draw on, and it gets trickled. I don't. Yeah.
Because I think what's common is the original solution or the variations.
Right.
That's what I think. If you did some noun verb stuff, that's what you'd come up with, and that's where, because unlikely you probably had more than 2 variations, you never saw the explosion. But in this case, in the original case of the CAD CAM, I might have 7 shapes. And remember, the initial scenario says 2, but there's going to be a 3rd. Right? So I have like 7 shapes and I have 3, so 7 times 3, and I have a 21 branch explosion of stuff, which if you only ever had 2, you'd probably do the pattern, you're okay.
Yep.
Right? I think very few people would come up with this particular solution where instead of having different kinds of rectangles, I have one kind of rectangle which has a drawing, and the drawing itself points to different programs. It's one level of indirection. I've moved this decision down one, but the beauty is now I only have to change that one thing, and then I get to only put the rules in the shape class. And that, I think, is what's confusing. Because if you look at this code after the fact, oh, that makes kind of sense, but I don't think you would write that from the get-go. I don't think I would write that from the get-go unless I'd been studying the design, the bridge pattern in recent past. It's like I had to re-refresh. I've seen this pattern before several times. Oh yeah. I remember this now. But I think if it takes someone who's seen it several times some time to refresh yourself, I think if you've never seen it, unlikely you come up with it. And that's kind of why I'm spending some time to hope you guys understand what's happening here. So now I'm going to point it to Andrew, who, of course, it's the new Google Hangouts, and I don't forget what the new button is.
So I think I kind of understand. My obstacle, understanding it, maybe I can present it like a case that I could see it. I might have like an application, and it could rely on a certain outside functionality, like let's say Unix. And it's like, oh, I needed to count lines. Okay, but to go back, it's like, how would I know when my drawing should use V1, V2? Would it be where it's installed, or where it's located, or what's available to it? Would there be logic in the drawing class to decide between V1, V2, or V3?
No, it would be in the instantiation of the object. So someplace else, you're going to have something that says, that knows, oh, I'm going to have a rectangle with this type of drawing.
Yeah.
Right.
Because the client shouldn't know anything about V1 or V2.
Right, and the client doesn't. But
okay,
there's
well, to some extent it does. In this program, the key line is the my factory equals new factory. That's the line that would be V1 factory, V2 factory, V3 factory.
Right.
That's the one place that you would decide in this particular program. And everything, but the rest of the program doesn't change. So if tomorrow there's a V4 factory, then that line becomes factory my factory equals new V4 factory. And then everything else in the client has to change. So the decision is always somewhere. You just try to move it back so it's decided hopefully only once.
Right. Like pretty much, it's hidden from when you want to draw, but not from when you want to create. Because like when you create these shapes, you know that you're gonna have a rectangle with a V1 drawing in it. Because someplace you have to instantiate this object, right?
Right.
So that knows that it's a V1 drawing and it's a rectangle.
Right, because that was the hardest part for me to understand. Because like I see the value of only calling a V1 or V2 draw action, but the thing was like, when will I see that I have different ways of implementing an action? And then like, who decides? Like, does the system decide? Is it like, so yeah, but no, the way you guys explained it makes sense.
Right. So everything is hidden from the client that draws it. That's kind of the idea. From the client that creates them, no, it's not hidden. But again, there's ways, through factories, other things that you can create this object and still, in a way that it's that's kind of hidden, like it almost like you don't care.
Yeah, I mean, if you look at every code, you try to minimize what you need to know. The client needs to know which factory, and that's it. Just draw. The shapes know how to. The concrete shapes know. Oh well, a rectangle is line, 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 line. So the rule's in one place. And I call this thing, I don't have to know what this thing is. The thing gets passed to me. Right? So he doesn't have to know. And then ultimately, only the drawing turns around and knows, well, I'm DP1 or I'm DP2. So you really minimize what you need to know, and for the most part, you're just very general. So the drawing being, those adapters need to know what they're calling, what thing they're adapting to. That makes sense.
Yeah, that makes sense.
But each one only had to know one thing, if anything.
But again, like I would like just this phrase over here. So the real power of the bridge pattern is that helps to see when to abstract the implementation they are present in the problem domain out of it, right? So over here says that essentially I'll have an entity X that uses system S, right? And then Y they use a system T. And I might think that they always come, X and S always couple together, Y and T always couple together, but then they start cross using each other. And they say like, oh, this is where I need like a bridge pattern. And like you can imagine like, oh, I have rectangle, they're always in V1, and I have circle always in V2. But then one day you say, oh, you know what? I figure out a way to do circles in V1 and vice versa. And now you gotta handle it. And if you start with a normal implementation, you end up with like an explosion of classes.
That makes sense.
And here you just don't. And again, there's an abstraction part, an implementation part is the main key of this pattern. It talks also about the bridge pattern often incorporates the adapter pattern because of the two implementation, two or more implementation. And the thing is, if it didn't have multiple implementation, it would be just kind of like what's a facade pattern style.
Yeah.
And again, although it's very common to see that adapter pattern is not part of the bridge pattern, but it does define it as a compound design pattern. So the intent is to decouple a set of implementation from the set of object that is using them. The problem is the derivation of a abstract class must use multiple implementation without causing an explosion of classes. So like they're going to define an interface for all the implementation to use, which is the draw line and draw circle, and a derivation, rectangle and circle of the abstract class to use those. The participants are so the abstraction defines the interface of the object being implemented, and the implementer defines the interface for the specific implementation classes, which is like again the drawings and the shapes. See. So one of the consequences is the decoupling of the implementation from the object that uses it, which translates also in the one row. And I guess like the other consequence I see is the one place for one rule, one place. And the implementation is like encapsulated implementation in abstract classes, and it's fine because like this is like a two times the word implementation. So the implementation of the parent is by encapsulating the implementation of the systems in abstract classes, or whatever the objects are being used in abstract classes. And the object abstraction contains a handle to that implementation. All right, so now we're back to where we left off, which is when using a bridge pattern, there's certain things that differ, they're like a language specific. So in C# and Java, when all the abstraction go away, the garbage collector will realize that and will clean them up. In C++, you have to do it yourself. which again illustrates an advantage of the garbage collector. I personally I thought you know, I was talking about last time that by not using an abstract class like in Ruby or languages like Ruby, you don't need to have an abstract class to define the interface, but it helps with the mental organization and the code organization, even though it's not necessarily necessary. I guess it's not necessary. It helps by kind of establishing what the rules are to have an abstract class or a class that to inherit from. Especially because there's not such a thing as abstract class in or base class. Like in Ruby, you'll see like an active record and stuff like that, like a base class, which acts as the abstract class, but Ruby does not have an abstract class concept. Let's see. So they say in the real world, we don't always start with multiple implementation, but we know that they are possible and that eventually will show up. One approach is prepare for multiple implementation by always using abstraction. You get a very generic application. But he does not recommend this point, and I don't either.
Yeah. That never overcomplicate things before you know it needs to be. That's kind of the reverse of the old Java classes, J2EE, all those things. It's just pattern. When you find out after using it for a couple, you know what? I never needed this factory. It's always the same one. Well, if you put a factory to abstract something that doesn't actually change, then it's complexity. You have to know the pattern, you know what it is, you know, and so don't do it. And I think part of the reason the bridge is hard is you don't have a lot of real world examples.
Right, and pretty much you said it a little before when you get to refactoring. When you have to add a new thing, yields a new system, a new implementation, you'll figure out what the commonalities are. Because you know, you can try and say, oh, these are the methods, but you're probably gonna get it wrong until you have the actual implementation from something else. I could talk maybe offline about the stuff I'm doing right now. I couldn't not guess the methods or how it would have worked ahead of time. I could like done like a abstract the payment systems ahead of time. All right. So, in summary, you know, the strategies, as it says here, is find what varies encapsulated, favor aggregation over inheritance, which are two of the Bingo 4 guidelines that they use like, to actually define all the design patterns. And this is like something that he talks about, consideration versus use. He used the word in different ways. He often talks about consider the pattern, because eventually it will say you need to use the pattern as a guideline, as a list of consideration. And sometimes when you use the word use, is that say not actually use the pattern. So if you use the bridge pattern, the design implementation are more robust and better able to handle changes in the future. If you just consider it, you might come up with some other solution, but you're probably even just considering it as a guideline, it will make your code more reliable anyway. So some of the stuff that is worth pointing out about it. Geometry are responsible for themselves. All the shape know how to draw its own, right? They know like a triangle will know to go from those 3 dots, a rectangle, you know, before, and how to draw a line, all that kind of stuff. The And also the implementation not are responsible for themselves, like the drawing classes. So the abstract class branches are used to represent the top level concepts, which are shapes and drawings. And it uses those abstract classes to actually encapsulate two types of things. One is the information, which is what kind of shape it is. And the other one is the implementation, which is the drawing portion of it, how this shape is going to be drawn. Again, one rule, one place. The stability I talked about before. So you have an N shape and M implementation. With the previous, you would have N times M. And now you have M plus N instead, which is a linear growth, I guess.
All right, so here's the pop quiz. Why is the bridge pattern called the bridge?
Because it makes a nice bridge between implementation and the objects that use it, so that you only call it once instead of having like little roots branching out, into M times N branches.
I think almost because of the diagram, it literally looks like a bridge.
Yeah, so there's two trees on the left. The left tree is shape, it's rectangle, circle, polygon, blah, blah, blah. And then the other tree on the right is DP1, DP2, DP3. So you're bridging between two trees, whereas the original is, I don't know how to describe it, but it's the explosion thing.
The original is a pyramid.
It's like a Mandelbrot.
Yeah.
Mandelbrot, that's reasonable. All
right, so define decouple and abstraction. Am I doing it, or do I call people on it?
You call people.
All right, I'm gonna call Don. Decouple and abstraction.
So just in general terms, I guess the decoupling is the behavior from the objects, and then the abstraction to just being like general abstraction of the objects we're dealing with, and using abstract classes. I see.
All right. Right. Yeah. Actually, yes. So how is the implementation define the context of the bridge pattern? I guess implementation is the actual point of contact between our concepts and the systems that they interact with that we have no control of. What are the basic elements of a sequence diagram?
I guess he must have introduced it in this chapter.
Right. I'm going to go with Andrew.
Oh, good. All right. So let's see. Imagine the sequence diagram is the one where you have the three levels. And so it kind of goes, hey, do this. And then there's a whole cascade of events that go on where either it calls itself, calls something else, or returns whatever it was supposed to call.
Right. So
to define it, I guess it kind of gives you both who it's calling or what message it's returning, plus some sort of time. First is like there's a cardinality to it. First it's this, then it's that. So it's able to do both really nicely.
Yeah. So you have all the objects represented. They interact with each other. You have the method that they call in the order that they're called. And pretty much you have like those three things.
Did they show an implementation? Did they show a system diagram for once you have a bridge, or did they only show for the non-bridge, like before the bridge?
They show only for the non-bridge.
Okay.
Yeah, so like you got a top level with the name, the method call, and the sequence that they're called in. Question.
Ooh, let me just ask. In the sequence diagram for the pre-bridge, it's kind of crisscross. One talks, then it responds, then it talks, then it responds. But with the bridge, would it be just one call and then several self calls from, let's say, DP1, and then it'll finally return something like the final implementation? Would that be okay, or so you see how it makes a call, then makes a call on itself, then makes another call.
Right.
DP1, then a call on itself.
Pretty much, you will not have this internal line to himself, because you would have the client called draw. Draw will call draw line, right? But will pretty much call it on drawing, and drawing will call it onto DP1.
So there'd be an extra object, the abstraction.
Right. So you have a client, you have a rectangle, you have drawing, and then you have DP1, and then it would be draw line, and then it goes back to here, draw line, and they all look the same in the same direction.
Yeah, in that one, my rectangle is also an adapter, but in the bridge pattern, it's not. The adapter is pushed down into its drawing program. So you pushed it back. I always keep going in a direction. Instead of client, rectangle, drawing, it's client, rectangle, which calls drawing, which does the adapting. Instead of adapting in the middle, you're adapting at the right.
All right, what is Alexander's view on how to use the pattern? Does he advocate starting with the solution first or the problem to be solved first? Forrest. Question. Yeah, Forrest.
Sure. Well, I seem to think he probably doesn't advocate in the solution, which translates to, okay, just code it, which unfortunately was almost the example of like all post patterns Java code. Oh, let's just do this. Oh, wrong pattern. No, you're going to look at the problem, figure out the thing, do the next question, which has to do figure out what's common and what's not.
Right.
Once you have the problem, then you know what pattern to use.
What does commonality analysis seek to identify? Commonalities pretty much is the abstract classes of the main concepts that are there, and the variability, like each implementation, a subclass that's going to happen. What is basic problem being solved by the bridge pattern? The explosion. So it's mentioned. Is that you get a bit more, like more flexible code between if new abstraction and new implementation are introduced. By separating them, pretty much you get a separation between the abstract classes and their own implementation.
This, I think, is the crux of why it's hard. It's when you have two things that vary independent of each other.
Right.
Which with the concrete, with the example here, we have shape. We could add a shape tomorrow. And we could add a drawing pattern tomorrow. So you have two sides which both can change independent, but they're tied. Right? And offhand, I can't think of, it's like I'm hard-pressed to think of another case. Like the exercise should be, let's think of all the cases that need the bridge so we have a better sense of why we want this. Because chances are you haven't had to do this, so you can't.
He mentioned printer drivers. So you say, hey, I need to print this page. You're like, oh, I can always have a new printer. Or, oh, I can always print a different page.
What varies on the left side?
What's printed? Like, oh, I'm going to print text, or I'm going to print color.
Right, but that's like kind of known right now. When I think of a printer, I think only the drivers do. You're just going to draw. You're going to write text, you're going to do fonts, you're going to draw things.
Yeah, but the printed driver are actually the bridge, right? So like on the, you're going to say, you're going to have like on the left side, you're going to have rectangle and this and this. You're going to draw a line, and on the right side, the printer driver are the various implementation. Because you got every printer has a different API internally.
Yeah, but I think maybe. I think of the printer drivers as adapters. Printer knows, unless when you print, you have different programs.
Yeah, that too.
I mean, I seem to think there's printer drivers are adapting some common format to specific printers. I only see the adapter. I don't necessarily see the part that changes that needs to bridge.
Okay, so define the one rule, one place. It's almost like the drive. Don't repeat yourself. Yeah. But I think it's up one level, because drive generally is like, people don't think about don't repeat yourself as like a method thing. So you extract a method that's used more often, like multiple times. But this is more of a, okay, by having one rule, one place, you actually are working towards specialized classes.
I still think it's dry. I'm just trying to keep.
Yeah.
You're just not duplicating. I think we come across the opposite, where, damn it, I have to cut and paste this because I can't think of how to abstract it.
Right.
I think we're more familiar with the inability to do so than the solution of. Anytime you're going, damn it, I have to paste this because I can't figure it out, or I don't have enough time to figure it out. Well, I just don't feel like figuring it out.
Right. What are the consequences of the bridge pattern? I said it before. It's a decoupling of implementation from the object that uses them, and also that the clients don't know, are not aware on any implementation specifics.
Yes. More robust code at the cost of more complexity.
Yeah. So the Gringo Force says the intent of bridge pattern is to decouple an abstraction from its implementation so that the two can vary independently.
I think we kind of discussed.
Yeah, we killed it. We killed it to death. Why can tight coupling lead to an explosion in the number of classes? Well, in this case, almost in any case, that is true, because actually, by tight coupling, you come up with like a class for each variation of some external factor, right? I'm trying to think of what would be like a good sample. I'm thinking of UIs. Like, imagine if every I cannot come up with a good example.
I don't know. His example, and again, it's understanding his example of the V1 shape, V2 shape, because they know how to draw themselves. That leads to explosion.
Mm-hmm.
Whereas the one rule of abstract rectangle knows how to draw itself, and you don't change that through inheritance. You change that by aggregation of a drawing type that knows how to implement that. That's how the bridge fixes it. Aside from that, I know it's hard to come up with that example. It's different than that one off the top of your head.
What about mobile apps? The ability to just write very simple like business rules and interfaces, and then be able to say, okay, now I want you like to work on iOS, or I want you to work on like Android. Is that kind of like, oh, you're implemented now on my Apple phone, or I can use you on my Samsung? Like, is that?
Well, in a way, you can, like, if you talk about decoupling at a very high level, like what was it, React Native does, you're decoupling coding from the final implementation, right? You're coding like in this like middle language with that then gets compiled 2 different ways or more for each thing. So you're decoupling from the language. So like, but is that what you were talking about?
Yeah, so like instead of having to learn a specific like language to code for iOS, I know something a little bit more abstracted, and then I can easily implement that without having to like say, okay, I need this functionality, but I need it to work on this specific phone.
Yeah, so like a React Native branch is kind of like an adapter pattern approach, adapter and facade approach to mobile development, because you write in common code that then gets translated to specific code in each thing, right? So it's an adapter style approach.
The UI is the adapter in React Native. You've defined a common set of widgets that are implemented differently on Android versus iOS.
Yeah.
But there's no left side, and your common language is JavaScript. So,
all right, let's see if we can finish this. Got 1 minute.
Yes, before, can I interrupt? It looks like those functionalities that we
No, keep going. Just joking.
Okay, so remember we were complaining about Google Hangouts? It's like whatever Forrest did to do this one, all the functionality's back.
I know.
Oh, you know what? Because it's the one from YouTube live events. So I guess they haven't upgraded this software yet to the standard Hangouts.
Yeah, I like this one better.
Yeah, me too.
We're running an older version. Well, I know. Yeah, because we just did stand up this morning and you have the new interface, right?
Yeah.
Yeah, okay. So I'm just saying YouTube hasn't upgraded their version of Hangouts yet.
All right, so look at objects in terms of their responsibilities rather than their behavior. How does this affect your view of the use of inheritance in an object-oriented system?
I'll give it a try.
Go for
it. When you think in terms of behaviors, the first thing that comes to mind for me is oh, well, is this a kind of behavior? Is it? And I start thinking of ISA relationships rather than the aggregation notion of it. So this already steers me more towards inheritance rather than aggregation, which is frequently the wrong direction. So when I think in behavior, that's what I'm thinking of, oh, inherited behaviors, because they're all ISAs of some kind of behavior. That's my jumping off point.
Oh, yeah, I like
you have to clearly pass that.
So, by thinking, looking at it in terms of the responsibilities, you think more of a ISA. Is that what you said?
Yeah.
Okay.
Yeah. It's an initial jumping off point, and it's the wrong initial jumping off point. Now you can correct pretty easily, but I like that responsibilities don't make that behavior assumption.
I kind of look at that sense as almost like rule of Demeter. Instead of behavior is knowing what they do down to the detail, whereas responsibility is what is he supposed to do, right? So it's like turn off the light. That's the responsibility. But the implementation may be walk over there and move your finger versus call out to Alexa.
And that would be the behavior.
Right, and that would be the behavior. Though I don't understand what that has to do with which like again, rule of Demeter. You just tell him. You don't care how he does it. You say, hey, turn the light off.
Right.
right? And so which doesn't segue into inheritance as well as Scott's opinion. But when I think about tell it, then rather than knowing what it's doing exactly.
And we already talked about this one.
Yes.
We finished it.
We did it. Yay. Okay, so next chapter is Abstract Factory, chapter 11. Who shall do it? Has anyone not done any?
Alex. I don't know. Not even here. All right. I'm gonna go.
Who?
I'm gonna do Angingo, tre civette sul comò per facere l'amore con la figlia del dottore, il dottore si amalo, Brett.
He just cast a complicated spell.
I figured he was doing eeny, meeny, miny, mo in Italian.
Yeah, that's what it was.
There you go.
Brett, are you okay with doing the chapter 11?
Sure.
Should I go again?
Brett, if you don't want to do it, you have to repeat from memory what he just said.
Yeah, just Google eeny, meeny, miny, mo in Italian.
It's called Ambarabachi Coco.
Don, you mind going? I don't feel like doing next one.
Sure, I'll do it.
All right. Don is the man.
All right.
All right. Thank you for listening to Nested Loops. Have a good day.
Bye.
Bye.
Bye.